Astronomers conduct most of their detailed studies of space from observatories. The site of an observatory is one of its most important features, as telescopes must be situated far from city lights, which overwhelm faint starlight. They are often constructed near oceans, as the air there is steadier, so the stars twinkle less, providing clearer images. Between about AD 180 and the 16th century, the Arabs dominated the field of astronomy. Their cultural centre was Baghdad, in modern Iraq, and it was here that Ptolemy's Almagest was translated into Arabic in the 8th century. The book was greatly extended by al-Battani, the most famous of the Arab astronomers. Instruments such as the astrolabe, an ancient Greek invention, were developed into precision tools, and the Arabs made more accurate observations of star positions than the Greeks had managed.
All the planets orbit the Sun in the same direction, anti-clockwise when viewed from above the North Pole looking south. Here we see the Earth and Mars moving around the Sun. Also shown is the path of Mars through the sky as seen from Earth, known as its apparent orbit. The Earth is closer to the Sun and moves faster than Mars, which seems to move from west to east in the night sky during the course of a year. Here, the Earth is catching up with Mars. If you looked at the sky on successive nights, Mars would be moving from west to east. As we get nearer to Mars and overtake it, the planet appears to change direction because it starts to move from east to west in the sky, as seen from Earth. Then, as the Earth speeds away from Mars, Mars resumes its usual path from west to east. The small backward loops in the apparent orbit of Mars, that occur about every 25 months, are simply a trick of perspective, caused by the fact that the planets move at different speeds in their orbits around the Sun.
Stars are born together inside huge clouds of gas and dust. The process begins when a region of a cloud increases in density. This change in density could be triggered by the passage through the cloud of a supernova shockwave, for example. Under gravity, the dense region contracts, becoming denser and hotter, and eventually forms one or more stars undergoing nuclear reactions. The gas and dust in the original cloud had a temperature a few degrees above absolute zero, minus 273.15 degrees Celsius or minus 459.67 degrees Fahrenheit. When condensed at the center of stars, this material has a temperature of at least 10 million degrees Celsius.
Stars are born inside huge spinning clouds of gas and dust. When a region in the center of a cloud gradually becomes denser than the surrounding material because of the effects of gravity, the temperature of this dense region increases and the heated cloud starts to glow. The dense matter slowly breaks up into hundreds of clumps of gas and dust called protostars. Each protostar spins and continues to contract and heat up. Eventually, the core of each protostar is dense enough and hot enough, about 10 million degrees centigrade, for nuclear reactions to begin, and the protostar becomes a fully fledged star. The gravitational field at the surface of a supernova's core is so strong that light leaving it is, to some degree, pulled back, depending on the angle at which the light rays leave the surface. Inside the contracting core is an imaginary surface called the event horizon. The closer the core gets to the event horizon, the stronger its surface gravity is, and the more the light rays are bent. Eventually, only vertical rays can escape. Once the core contracts beyond the event horizon, no light can escape at all. To an observer, the core would seem simply to vanish. The region inside the event horizon is called a black hole, because nothing inside it can be seen from outside. Inside the hole, the core continues contracting until it becomes a singularity, a point of zero volume but very high mass. The gravitational field of the singularity may attract gas from a nearby star. The gas forms a swirling disk around the hole before disappearing into it. Pluto and its moon Charon take exactly the same time, 6.4 Earth days, to orbit once around their common center of mass. During each orbit around the common center of mass, Charon also rotates exactly once about its own axis. This situation is called synchronous rotation. Like Charon, Pluto also rotates once on its axis during each orbit of the center of mass, and so it also has synchronous rotation. This means that the motions of the planet and moon are locked together. An observer on the side of Pluto that faces Charon would see the same side of the moon fixed in the same position in the sky at all times. An observer on the other side of Pluto would never see Charon.
This computer-generated image of Venus was created using radar data from the Magellan space probe. This journey begins with a flight over a 1,000-kilometer-long rift valley in Venus's northern hemisphere. Ahead is Gula Mons, one of Venus's many volcanoes. On the other side of its summit are many bright streams of solidified lava. The journey continues over the jagged ridges of Alpha Reggio, a highland region in the southern hemisphere, and finishes with a view of a small crater unofficially named the Tick. In this external simulation, you can see the shuttle orbiter move towards Mir. The orange object in the shuttle's payload bay is the specially installed docking port. Here you can see the view from this docking port as the shuttle approaches the space station. The dark target area inside the Mir docking port is used to keep the shuttle centered on its approach. After the docking, Shuttle Commander Robert Gibson ensured that the air pressure inside the shuttle matched that of Mir before opening the hatch. He was greeted by Mir Commander Vladimir Deserov.
The Big Bang occurred around 15 billion years ago. The first hydrogen and helium atoms formed within minutes of the explosion. These eventually turned into clouds of gas, which around 14 billion years ago began to condense due to the effects of their own gravity. Over the next 2 billion years, the first galaxies began to form from these clouds of gas. Our galaxy, the Milky Way galaxy, began to come together around 10 billion years ago. Within this galaxy, our own sun was born around 5 billion years ago, with the planets, including Earth, forming from the surrounding disk of spinning gas and dust. What happened in the initial moment of the Big Bang remains a mystery, but it's likely that after only the tiniest interval, the universe was still smaller than the nucleus of an atom. Almost immediately, the strong nuclear force and the electromagnetic force separated, providing the energy needed for the universe to start inflating. Before even a millisecond had passed, the universe had grown to about 3 times the size of the Sun. Continued inflation caused the universe to double in size every fraction of a second.
Three, two, one, ignition, liftoff.